Hello, welcome to PhyzQuest. This is the solution video for CSIR NET December 2019 Part C, question number 2. The question is, the function ft is a periodic function of period 2 pi. In the range of minus pi to pi, it equals to e to the power minus t. If ft is equal to summation over minus infinity to plus infinity cn e to the power int, which denotes its Fourier series expansion, the sum of summation over minus infinity to plus infinity modulus of cn square we need to calculate. 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section Mathematical Physics, and the concept involved here is the Fourier series. So in the given question we have a periodic function ft of period 2 pi. So ft is equal to e to the power minus t in the range of minus pi to plus pi. The Fourier expansion of ft is given as summation over minus infinity to plus infinity cn e to the power int. So we need to calculate summation over minus infinity to plus infinity modulus of cn square. Cn is actually the coefficient of the Fourier expansion. So here we are given the Fourier series expansion and we need to calculate the sum of the square of the coefficient of the Fourier expansion. So in order to calculate that, we have to use an identity known as Parseval's identity, which states that the sum of the squares of the Fourier coefficient of a function is equal to the integral of the square of the function. So mathematically, if you want to write it, sum of the square of the coefficient of the Fourier function, which is summation over modulus of cn square, will be equal to 1 by t integration from minus infinity to plus infinity modulus of ft square dt. So here capital T is the period for time period or the period of the expansion, and ft is a given function, and minus infinity to plus infinity is the range of the function. Now in our case, the time period or the period of the function is 2 pi. The range of the function, instead of minus infinity to plus infinity, it is minus pi to plus pi, and ft is given as e to the power minus t in that range. So if you put all this information in this expansion, in this expression, it will become 1 by 2 pi integration from minus pi to plus pi e to the power minus 2t dt. So upon integrating this will become 1 by 2 pi e to the power minus 2t divided by minus 2 from minus pi to plus pi. So minus will be multiplied, ultimately this will become minus 1 by 4 pi e to the power minus 2 pi minus e to the power 2 pi. So if when we multiply the minus sign with the bracketed term, it will be give the final expression 1 by 4 pi e to the power 2 pi minus e to the power minus 2 pi. Now we have a trigonometric identity, that is hyperbolic of the sine hyperbolic x, which is equal to e to the power x minus e to the power minus x divided by 2. So we can use this identity in this expression. So we can rewrite this expression as 1 by 2 pi e to the power 2 pi minus e to the power minus 2 pi divided by 2. So now we can use the sine hyperbolic term. Instead of x, here we have 2 pi. So ultimately the final expression will be 1 by 2 pi sine hyperbolic 2 pi. Now let's check the option. So if you check the option, you can see that option D is matching with the result. So correct answer for this question is option D.